Here comes the brief. The aim of the project is to design a self-sustainable development based on a 1 hectare area block. As well as being self-sufficient, the development itself also needs to achieve a higher level density as much as possible for this project. The idea behind for this development design project could be alternative to the standard 12 or 15 dwellings per hectare development, which is also most commonly seen and built these days.
To respond to the brief, our first point of action was to figure out how many people a 1 hectare plot of land could sustainably support. Looking at the power requirements, we found that using the most efficient solar power generators, solar Stirling engines, it would be possible to have well over 100 dwellings powered self-sufficiently if an array of roof collectors was utilised.
The problem being that to grow enough food to feed the average person would require about half a hectare of land, allowing only 2 people to live on the block, with most of the area being taken up by agricultural land. If the occupant were completely vegetarian, then this brings their land requirements down to 0.1 hectare each, but this still only allows 10 people per hectare. Given that most people today don't actually grow all our own food, if any, we thought that perhaps we should just allow for a maximum amount of food grown. Example, just the fruit and vegetables on site, with the rest being allocated to be grown elsewhere. Taking the average rainfall of Melbourne as 650 millimeters per year, this means that for a 1 hectare site, up to 6,500,000 litres of water can be captured per year. Using water liberally at a rate of about 220 litres per day, as most Melbournians do today, this would mean that a 1 hectare site could support 80 people, a density approximately double most suburban developments these days, which we felt was a good basis for our design.
The design was based on a single unit of inhabitation, and this was replicated 17 times to create enough housing for 80 occupants. These units were then placed in such a way to provide maximum solar penetration and insulation, and also try and create a close-knit community on site. Greenhouses were placed on the second and third floors, as well as on the roof, to provide insulation for the building, as well as obviously to grow crops. 4 solar collectors on the roof would be able to provide enough electricity for the 80 people's use, and water collected from the roof as well as adjacent greenhouses would be enough to provide for the 80 occupants, as well as for the hydroponic system in the main building and the crop rotation located in the adjacent greenhouses.
This design is just one of the infinite number of possible designs which represent real alternatives to the standard suburban development perpetuated for the sole reason that it is the most economical form of housing. Overall scheme, this proposal will try to use environmental friendly design, making full use of the sun to provide energy, aquaponic as food, and also acts as fertilizers to the crops. In another word, bringing architecture back to nature.